right, hey, what's going on, everyone? I'm David Novicki, and the title's a little misleading. It's not going to be 5-minute talk, okay? But hopefully I can show you how to deploy in 5 minutes. So I'm going to kind of tell you a little bit about the background of what serverless is, what microservices are for those who don't know, and kind of how we at Dervata approached some problems that we were having and how these became solutions and the ways that we created solutions out of our problems, really. But real quick, who am I? I'm the VP of Engineering at Dervata. It's a big title. I run a small tech team for a startup here in Sacramento that is kind of like a WebMD meets Skin. So we try to bring technology into how people handle their healthcare. I consider myself an entrepreneur. I am a event organizer for Sacramento Startup Developers, which is a new meetup here where we just kind of drink beer and talk shop. My interests really are anything JavaScript, love it, and newly deep learning. So I always love to talk about deep learning. So if you guys, anybody interested in here, please grab me after. So first things first, what is a microservice? This is kind of like sometimes an easy answer for some. Otherwise, it's a little bit complicated for others. There's not necessarily one de facto solution for what a microservice is. The best way I like to put this is it's some bit of software that has a task that's independent of other things. You try to not muddy it up with dependencies on outside things. So we want it to run, sit somewhere, do a task every time, hopefully, and not be muddied up by any kind of other unrelated services. What is serverless? Serverless is somewhat new, and it's it's kind of going around. People are like, how do you have something that's serverless? Everything needs to run on a server. And currently that is true. But what it is using our kind of cloud service providers to handle the server side of things completely. And what you do is you give it a function, and your cloud provider will run that function and will scale that function accordingly. So you actually do not have to worry about your server being up. You don't have to worry about little things like that. It's very resilient, and sometimes it can be really fast. And how it works, they're just functions. So I stole this picture from Amazon because we use Amazon at Dervata. And it's a great picture. It actually shows you really what it is. They use AWS Lambdas, and Lambdas are just functions. So you upload your function to AWS, you configure it, certain permissions, kind of what you want it to do, what it's receiving requests from, and then you only get billed when it runs, which is probably right now one of the top contending reasons why you should go serverless. You don't have to pay for uptime. So as a startup, when we're growing or new services are growing, our AWS bills can be pretty high and traffic is starting to climb. So it kind of gets sticky, and so serverless helps us kind of pay per use, really, which is, and it's really cheap. I didn't put the price on here, but you pay per million requests, and it's something very minimal. What cloud providers support serverless? So like I said, we use AWS. Don't have much experience with the other cloud providers, but Microsoft, Google, a lot of these other ones that some of them I've never even heard of, but they all provide some kind of serverless architecture. They can vary differently. They're not cross-compatible, but same idea. So, the biggest question is why use serverless? It's kind of a hot trend. It's kind of a topic. It's not fully ironed out yet, so you have to decide, is it actually practical? And for us, it is. No server management, flexible scaling, which is great. They will go ahead and adjust. You can toggle little units or toggle units for your functions to adjust rather than trying to scale up servers, which is huge, especially for a small team. High availability, it's very great. And like I said before, it doesn't cost you money just sitting there, only when it's being used. So I put up this really crude diagram, and it's just because seeing visual pictures really help me when I'm kind of trying to observe these things. And so really, how we use this, we still have a RESTful API, but a RESTful API is a hub for a lot of our microservices. So we kind of had this hybrid approach as we're switching over to a lot more serverless microservices. And so what we do is every time we have some kind of new function or something we're building for during beta, we spin up a microservice that talks to our API, and our API talks to our front end. So it lets us just add a chunk each time as we go for each new feature and keep building upon it. So you kind of just see, imagine this is like the browser or whatever using it, communicates to the API, and the API routes to the microservice. And that's generally how our structure is. Other people do it very differently. I find that this works, and so far it's scaling with us. But what about some other issues? So when I first heard serverless, I was probably the biggest critic. I talk a lot of trash on it. And the reason for is because it's like you have all these functions that are just hanging around everywhere. How do you maintain them? Running a software team is hard enough on its own, and then trying to keep track of what code corresponds to what, it can be a nightmare. So maintainability is really big. And so I'm not going to answer the solution for this yet, and hopefully you'll figure it out through I talk. But keep that in mind as well. The other thing is organizational structure. You don't realize it, but as a software developer, if you jump into new code, you kind of learn about its structure, and you learn relationships based on how the code's structured. That's really big in understanding a platform or a service or for everything that we do, honestly. And then lastly, permissions and security. How do you handle that? If you have all these different microservices, how do you handle consistent permissions? How do you not open up another security hole every time you launch a microservice? And that's very important. So we'll get back to those. But enter in serverless. So a little disclaimer, serverless is a terrible name for this. It's a framework, okay? So there's serverless architecture, and then there's serverless framework. So I'm going to boggle a lot of you guys' brains a bit going over this and keep saying the same word for two different meanings. But serverless is a framework, and all serverless does is it manages microservices for you by following a certain standard. So using something similar like a package.json, you can put different key value pairs, different configuration options, and it scales your microservices accordingly. So coming from JavaScript with package.json and dependencies, it really feels the same, so it's very natural to get started with this. It is still early stage, but at the end of the day, it just kind of organizes everything and then pushes it up to your cloud provider. So if something goes wrong or something's not working properly, it's not very hard to jump into your cloud provider and kind of make the adjustments, although we have not had that issue yet. So like I said before, all it is an organizational tool. It's not magic. You have what's called a serverless.yaml, and you set your config in here. So you can set who your provider is, AWS. You can set your runtime, Node. They do Python. I believe they do Java. Depends on your cloud provider, really. Stage, which is similar to like development or production, really whatever you want to call it. Region, if you want to have a specified certain area. We do everything and typically start in Oregon, just because it's close. But by default, serverless uses Virginia. And then you put your functions here, and these point to a handler.js file, and this is just a JavaScript file that has a function. And so you see the handler.js down here. It's called hello. That's my function name. And then it takes 3 parameters, and that is consistent with what AWS Lambda needs. So you implement your code there, and upon deployment, whatever's in your function is going to run for that AWS Lambda. So rather than just kind of point you at the screen and just talk about it, I figured a real live demo could be suicide, or it could work out great and show you how easy it is. So we're just going to code it real quick, or at least spin one up. So let me pull my notes out for this, otherwise. Okay, who has experience with the AWS CLI? Much people in here? not very many. You have to install AWS CLI because serverless kind of wraps around a lot of those commands. And with that, you have to set up your credentials. And setting up credentials in AWS is pretty easy, actually. How it works is, let's see, can you guys see this? Probably not very well, huh? When you log in, this is your main screen right here. IAM is what it's called. And you create basically a key and a secret. And I'm not going to do that all right here, but after you've created it, you have to add administrator access, which isn't ideal right now. They're still working this out. But because you're managing things like an S3 bucket and a Lambda function and API gateway, you need a lot of access. They haven't give clear-cut standards of what exactly access you need, which is unfortunate. That takes some playing around with. So, but once you've created a key, you can go ahead and add it to your config on your machine. So once your AWS CLI is hooked up, you're good to go. You can install serverless. So this is actually pretty easy. You guys are all familiar with this. You install it globally, and it's a CLI. So by using serverless, you can run certain commands and it will do everything appropriately. So it makes big, complex tasks simple to singular tasks. So after this is done installing, we really want to create a project, right? So we want to create kind of whatever our microservice is going to be. And let's say it's a hello world, really. So I'm going to type in serverless, create. And then you need a template. So AWS node.js is, according to their documentation. If you had a different cloud provider, this is where it would change. So you can say Microsoft or Google. So, and then you need a path. Once that's all done, just like Git, kind of puts together a folder for you with this project with everything that you need. So I can go ahead and change to it. So in here, I hope you guys probably can't see it. Just like I mentioned earlier, it has a handler and a YAML file. Very simple. The root of what's behind this is once we start publishing. But in your serverless.yaml, you have a service. You have let me move this. This is pretty obnoxious. You have the provider, which is AWS, the runtime, which is the latest version of Node that AWS runs for us, 6.10. And then they give you a kind of a hello world function right off the bat. So you get the function name, you get the handler that it's attached to. And in that handler, they've given you more boilerplate of a response. It's an object that mimics similar to an HTTP request, where you can put a status code and a body, etc. And so if we want to get this actually up and running, it's actually one command. So we can say serverless deploy, and verbose for me because I want to see it actually, all the console logs of it, packaging everything together. And what serverless does is it takes your package and it puts it together in a zip file, and then also creates a bunch of CloudFormation templates. And this is, many of you guys might not know, but for those who do, CloudFormation templates are a JSON file that scales to AWS. So it gives it this JSON file and it says, hey, I need a Lambda function, maybe an API gateway, whatever configuration I want to put in my serverless project, and it deploys. So when I come for a new version or some changes where I want to add some more instances, some more Lambdas for whatever reason, I can just add it to this CloudFormation file and AWS will scale it for me. So serverless just kind of wraps that on another layer, makes it pretty easy, and also kind of saves you for version control. So if you need to regress back, you know that each instance of your AWS Lambda functions are saved in your S3 bucket, which is pretty big too. So very easy to kind of revert back. But once all said and done, it gives us a nice little console log. It tells us, the region that it was deployed in, the stack, which is our CloudFormation stack, the stage that it's in, any API keys or endpoints. In our case, it's just a function. So it tells me the function's hello, and it tells me similar to what its name and its ARN is. So from this, I can actually just kind of call it. And I'm going to show you that it's actually in AWS, but from this I can invoke it, and I get my response object back. So I get, their boilerplate, go serverless, blah, blah, blah. And this is actually coming from AWS. So just to kind of give you an idea of what's there, we can go to AWS Lambda, where our function's living. You can see it actually right here in Virginia. It was important that I chose the East region, otherwise it's not going to show up. You can see the actual code that it uploaded. If I go to, oh, no, that's it for now. So that's cool. It doesn't do that much for us right now, but we have a function, and it's up on AWS. But what's really important is, for the most part, you can test this locally. We do a lot of testing through AWS. It's a little slower. But what it actually lets you do is jump in, and you can actually feed logs from your Lambda as you're testing it through CloudWatch. And so Serverless gives you that option, and you can say serverless logs, the function name, and it actually opens up essentially like a socket to CloudWatch logs. So it doesn't tell you much unless you're erroring out. But if I wanted to request this again, real time without actually having to pull the log, I can see exactly the request came. It's going to tell me that it finished. It's a little delayed. It's not totally ideal there, but it's good for error logs. So CloudWatch will log any issues that it had when it was running your Lambda. So going forward, and AWS Lambda is great, but it doesn't really kind of get us the whole distance, right? We have an AWS Lambda, but typically microservices, people like to communicate with them via like a REST API. Have kind of an endpoint they can hit, not having to use like the AWS SDK to talk to a Lambda and do the whole deal. So serverless lets you do that. It's through, for this case, it's through AWS API Gateway, which is just kind of like a front hub for all your requests coming in that will execute whatever Lambda functions that you attach to it. And I hate GUIs. I hate going through the process of like trying to configure, especially AWS. I don't find them user-friendly at all. So serverless letting you do this is actually, so all you actually have to do is we go back to our YAML file, and we add an events property. Under that, we add HTTP. So we want the path that we want this to go to. And this is just at the root path. So I'm going to say path, SacJS is going to be our path. The method is going to be a get. I need a space up there. And we want cores to be true. Okay, so from this, we're telling serverless, like, hey, like we want you to create an API gateway. We want an actual endpoint for this function. And then serverless will do all that for you. So all you have to do is actually say deploy again. Of course, it's, oh, an error here. Let's see. HTTP. What did I do here? I told you live demos were suicide, so let's see. I have this in make sure I didn't mess that up. I think it was a space. Serverless.yaml is not always the friendliest. It's not like your package.json where you can kind of add arbitrary spaces elsewhere. It's very sensitive. Everything's based on tabbing and spacing. So in that case, I didn't have an extra space after my dash, and it didn't like that. But copy and paste is always your friend here. Their documentation is really great, actually, for being so new. So a lot of things have changed here, so it's going to take a little bit. But you can see in a lot of these console logs that it's sending to API Gateway to deploy some kind of front-facing to our AWS Lambda. And it's actually done so. And so it gives us back an endpoint where we can actually test our function. So we can test our function the way that we did before, which is just going to test the Lambda. But if we actually want to test our endpoint, all we have to, choose Postman or curl, whatever you like. Just call it, and this is a lot of mess, but you'll see Go Serverless right here. So it's actually got an API gateway. Our Lambda's sitting in front, and essentially, writing some more code, we deployed a microservice. Now, some of the little caveats here are where your security comes into play. So what are you going to stop people who are not unauthorized to actually access your AWS Lambda? And so you can actually do that with another Lambda. So I can just deploy a microservice that checks, that intercepts any requests that are coming to it, and it can reject them before they even get to the other AWS Lambda. And serverless makes it really easy to talk to this. Is you can actually implement it directly in the code here, or if you want, you can add authorizer, and then whatever the ARN is there, add it there. As long as it exists, it'll add it in front of it, and it will reject anything based on that custom AWS Lambda that you have. So then you add your layer of security. So I find this incredibly useful because we have a handful of authorizer functions that we use in a lot of different areas depending on what a security or what the service is. And you can do things like JSON Web Tokens. You can stand that in front and take their token and get the user and pass it on to the next Lambda, which is really huge. And especially if we come from a node API, and we do a lot of the same things. So it's really important that we can kind of grab who that user is and then take necessary information before they even get to our next function. But for the most part, we actually have a service up and going. To show you guys proof, I showed you the Lambda. Now if I want to go to the API gateway, I can see SacJS hello world. Through here, I can see that I have a GET request. I can test through here, but honestly, testing through the CLI is 10 times better. This whole GUI is not very user-friendly. They tried to make it, but it's actually way quicker through serverless. A lot of people, what they actually do, an extension of serverless, is you can run a mock API gateway in AWS Lambda locally. So you can actually test a lot more rapid fire. We don't use that currently. We prefer to test in an environment that's very similar to what we're using. But as those tools develop, they're going to get really strong. But so I have this up. Everything's kind of been deployed. I can have my service do whatever I really want it to do. But in this case, I actually don't want it. So there's a lot of overhead of stuff that I want. I want to be charged. It's not much, but I don't want to be charged because maybe I don't want the service. So serverless thought of that, and they actually have a remove function. And so through this, it actually pulls everything out of S3 bucket. It deletes your API gateway, and it removes all Lambdas, which is nice, especially when you're not trying to get a bill for it. So as that's going, let's open this back up. I want to bring back this slide. And this is really, what about maintainability? So what I hope I showed you guys is the serverless.yaml is really good for structuring your app. It's predictable, and that's what's really important. Everyone's used to seeing it from microservice to microservice. They follow the same pattern typically. Organizational structure. Serverless.yaml does the same thing. By making that kind of the parent of your entire project, it forces you to really have structure. So it's really hard not to follow that process because serverless completely surrounds it. And it's all code-based, which is huge. And permissions and security, which is using a custom authorizer function that sits in front of your Lambda. Serverless covers that as well. It covers that with ease, which is really important. So there's not really an excuse for not having an authorizer in front of your functions or not having that security or those permissions. And that is it. So I have a GitHub repo. My email if you guys have questions. I also have a Medium article about this that's much more in depth about creating a microservice with more use, which is like creating and getting users, and actually talking to Mongo. So find me on Medium, Dave Novicki, or if you have any questions, feel free to talk to me after. But that's it. Thanks, guys.
Does anyone have any questions for David before he?
Yes.
I'm just curious, like, what is your preferred length for a function that you found for deploying?
Like length?
Like how many lines would you say?
That's a tricky question because what you want to try to do is structure your AWS Lambdas to be actually pretty small. They call external libraries, so you're not dependent on AWS per se. So tomorrow, if we wanted to move over to Microsoft or Google, our whole library is built out for one function calls to add users, to get users, et cetera. And it's very minimal to change that. So I would say really short, then you're coding for use elsewhere down the line. Oh, did I answer your question?
Yeah, like I was thinking like 200 lines, but that's way.
It's typically very small, very small. And
you're like 10, 20 lines.
Very easily, yeah. Now it depends what the other functions do. If they're saving users, but our microservices are very task-oriented. So if we have to, process some data about a user, that's all it will do. It'll process that chunk for that user, and then it'll be done. AWS Lambdas have timeouts too. You can change them, but it's best not to assume that your microservice is going to be like this big, robust thing that does. You want to do small tasks that hopefully will be done pretty quickly. So that's our goal when we create them.
Where does it go to the library from? Where does the library go? Sitting in the Lambda or some other?
It goes with the projects, but we're able to take those libraries and make them their own, just JS libraries through
so when
NPM.
You deploy together.
Yes, but if it changes, then we update the version or reinstall with the new version, and then it has updated code, and you're good to go. So, yes.
How do you handle database access and kind of storing state?
So you have full access that you do like in Node. You can, like I said, I access Mongo. It has better support for accessing AWS resources. You have to add permissions, which you can do all through serverless.yaml. So if I want to access DynamoDB, I can add those access to serverless.yaml and tell it kind of what it needs to do, and then it will give access and you can pull it in. We don't use a lot of AWS dependent things. This is probably the most dependent that we use, and we code it in a fashion that if we need to migrate, we can. That's just our preference, but it's really it's platform specific, friendly. Anybody else? Cool, thanks.